Hello, let's continue our Sudoku adventure with some pointers by the Asylum. So we do have standard 6x6 Sudoku rules, meaning in every row, every column, and every 2x3 box, we are placing the digits 1 to 6 exactly once each. We also have these arrows in the grid. These are standard arrows, so there's an arrow and it's attached to a circle. Digits on an arrow sum to the value in the circle. So if this was, for example, 2, 4, 2 plus 4 is 6, we would put a 6 in the circle. Digits can repeat as long as other rules allow it. So, we can't repeat here because Sudoku disallows it, but the arrows do not add any additional non-repeat rules. We like to specify that for any sum constraints, because if killer cages are your first constraint that you're used to with sums, you might think that the non-repeat is standard, but actually killer cages are one of the few sum constraints that actually add a non-repeat explicitly. Anyway, those are the rules. There's a link in the description if you'd like to try the puzzle yourself, and I'm going to get started right now. Okay, well, so this has to have a 2 on it, and it's going to add to 5 or 6, right? The minimum is 2 plus 3, because there's a 1 here. Minimum is 2 plus 3 is 5, or we're going to be 2 plus 4 is 6. And there's definitely a 2 on this arrow somewhere with a 3 or a 4. Here, this is given. The minimum you can put on 3, these can't repeat because they're in the same column. So the minimum is 1 plus 2 plus 3, which is already 6. That's our biggest digit. So we just immediately can fill 1, 2, 3, and 6. I need a 6 in this row. We're not putting a 6 on an arrow, because then you'd have to add it to something else and get something bigger than 6. And then this 6 says not here. So we can actually place the 6 in this row, and that gives us the 5, which makes this a 2-3 pair. This no longer adds to 6, but we already have 2 of 1, 2, 3 used up. So this is quite limited, right? So what do I mean by 2 of 1, 2, 3 is used up? Well, this is 2 or 3, and this is 1, 2, or 3. I can only have one more cell in this row that is a 1, 2, or 3, right? If I tried to make this 1 plus 2 is 3, this would be 3, and this would be nothing, right? Or it'd be also 3. So we only get one more of 1, 2, 3. Even if it was a 1, it then has to go with a 4 or a 5. And so I think the answer is we have to be 1 plus 4, right? Equals 5, because this can't be 6. So this caps at 5, and this sum here, the smallest I can do is 1 plus 4. The smallest of 1, 2, 3 I can put in is 1, and then that uses up the 2 and 3. And then the smallest digit I can add to that is 4 then, and that already adds to 5. So if the smallest digits are already the biggest that we can put in here, that's what happens. There's no room for wiggling. So that can't be a 1, and this is our 5. Could have also said there's no way we're putting 5 on here because this maxes out at 5. That would place the 5 here, but I still think you kind of need that logic of this needs to be a 1 and a 4. Maybe there's other ways to think about it, though. Let's see. This could be a 6. In fact, this is a 6 by Sudoku for the box. So how are we adding to 6? We can't do 1 plus 5. The 5's gone. So we are doing 2 plus 4. And that makes this a 3 and a 1 and a 2. And a 4, 2. All right. And so now this is the other 1, 3 for the box. All right, we have a couple more arrows here, but let's do some Sudoku if we can. This is a 4, 6 pair. So that means this is not a 4 or a 6. That's quite limiting. We know there's a 1 in one of these two cells. So this is 1. So this is consecutive with what other digit goes here, which means this can't be 5. Because if this was 5, this would have to be 1 plus 4, because it has to have a 1 on it, but 4 is gone. So in order to be consecutive, this actually has to be 3 with a 1, 2 pair. That's really interesting. So that's our 5. 1, 2 pair gives us 4 and 2. This is a 3. These two digits are 4 and 6. The 6 tells us the order. Nice. All right. So these two digits add to this one. This can't be 3, 4, or 6. And 2 digits add to at least 3. So can't be 1 or 2 either. So this can just literally can only be 5. And so this is going to be either 1 plus 4 or 2 plus 3. If it was 1, 4, we can go in any order. 2 plus 3, this 2 tells us it would be 3 here and 2 here. But we don't actually know which one it is. One thing I will say, though, is we have a virtual pair here. I'm going to explain it even if it's not necessary for the puzzle, because I think virtual pairs are really neat. This is a 1 or a 2, And this is going to be 1 plus 4 or 2 plus 3, meaning that one of these cells will also be a 1 or a 2. So we don't know which cell it is, but that the cell that is the 1 or 2 on this sum creates a 1-2 pair in the row, meaning this cell cannot be 1 or 2. So it's down to 3. It actually can only be 3. And in fact, if you just look, there's only one place for 3 in the row. But I thought I'd actually no. Sorry, no, there wasn't. This could have been 3, but that doesn't actually work because this can't be 1 or 2, and it can't be 4, 5, or 6. So it's limited to just 3. That's actually a good way to finish this, I think. So that's a 1-4 pair now because 3 is gone. So that gives us the 2 and the 1 and the 6 and the 4. This is 2 plus 6. This 2 gives us the 6 and the 2. This pair is 1, 2. That seems important. Gives us the 3 and the 1 and the 3. It gives us 4 and 1. These two digits are 4, 5, and we're done. Really neat puzzle, Asylum. I liked the flow of it. Starting here and here seemed to work well, and then the logic of this being 1 plus 4 equals 5, and then I liked the logic of this being 1 plus 4 equals 5. Or sorry, the logic of this being 5, a naked 5, and then a naked 3. Really interesting. Cool. Well, hope you enjoyed it as well. If you did, then why not leave a like, subscribe, and a kind comment below.